Hi, we'd like to welcome you to another in a series of webinars designed for departments of transportation. I'm Terry Bills, and I'm the Transportation Industry Manager here at Esri. And today I'm joined by Travis Franz and Jacob Pellmann from Mandli Communications and Stan Burns from Integrated Inventory, both outstanding Esri business partners. Today's webinar is really focused on how you can create an effective pavement management program at your agency. This is different from talking about a pavement management software package, but rather it's how can I put together a methodology and a workflow that will allow me to effectively analyze my roadway segments and how I can put together a capital improvement plan that is understood by the rest of the agency and can be part of the transportation planning process. I hope you'll see the following presentation as a way of demystifying the pavement management process. Before we begin, I'd like to point out that we are recording this webinar, and while everyone will be on mute, there will be time for question and answers at the end of the presentation. You can type your questions into the question box at any time, and we'll try to answer as many as time allows at the end. Additionally, the slides that are part of today's presentation will be made available to you on the GeoNet group, Departments of Transportation, and you can access it, the slides there. In addition, this webinar will be posted over the course of the next few days. So if you'd like to see it again, or if you would like to have a colleague view it, you'll be able to access it again. Since we're going to cover a lot today, I don't want to waste a lot of time, and I'd actually like to jump right into our presentation, and let me introduce our speakers. So from Mandli Communications, we have Travis Franz, and he has over 15 years of experience in the geospatial industry, and he recently joined Mandli Communications. He's currently involved in leading not only special projects, but also actively supporting their consulting and business development efforts for Mandli. And then we have Stan Burns, and he, after his retirement from Utah DOT, has been an independent engineering consultant. His company is called Integrated Inventory, and he and Mandli have developed an integrated pavement management solution, which is built in ArcGIS, allowing viewers to view, edit, manage, and analyze pavement data. And then finally, Jacob Pellmann has worked at Mandli Communications for over 7 years, solving geospatial problems related to assets and pavement data needed by engineers at both the state and local levels. As the pavement product manager at Mandli, Jacob provides oversight on all pavement-related deliverables and has assisted in the implementation of a simple pavement management solution on the Esri platform. And with that, Travis, let me turn it over to you and to start us off. So take it away.
All right, fantastic. Thank you so much, Terry. Good morning, good afternoon to everyone out there. Really delighted to be here today. You know, on behalf of the Mandli team, I want to thank Esri, I want to thank you, Terry, and really the transportation group as a whole for inviting us to speak with you today. So as the title suggests, pavement management and GIS, we're going to be discussing GIS's role in pavement preservation and management. You know, really a kind of a cradle to grave view, you know, all the way from pavement data collection in the field to data calculations and assembly back at the office to validation, data analysis, and then ultimately, you know, the integration of this pavement data and visualization of it, most importantly, in an ArcGIS environment. And all of which really, especially on the back end with visualization, you know, helps arm decision makers and maybe non-GIS folks in organizations and gives them the tools to make, you know, these smart cost-effective decisions about pavement and really their overall asset network. So before we jump into that, I think it's fair to give everyone a little bit of background, a very brief background about Mandli Communications. I'll then we'll turn it over to Stan and Jacob, who are really our the resident pavement experts on this call. And they'll be going into some of the pavement preservation and the methodology system that we've adopted and really cultivated at Mandli. And then again, we'll talk more about, they will talk more about ultimately how that data is being integrated and visualized within a GIS using Esri technology. And then of course, leaving some time for some Q&A at the end. So, as Terry mentioned, my name is Travis Franz with Mandli Communications. So Mandli is a small family-owned company, just kicked off our 37th year in business. We're about 150 people strong, based in Madison, Wisconsin. And really we pride ourselves in our core business, which is an industry leader in specialized highway data collection with integrated pavement technology, mobile LiDAR, and just overall geospatial technology equipment that really supports not only the public and private sector, predominantly DOTs within the U.S. Data collection, what I kind of think is the most fun and interesting part about what we do, is really done using two chief methods, very, very different from each other, yet a lot of commonalities. On the left is our X35. That's named after, we coined the 35 in our 35th year of existence 2 years ago. We have about 8 of these vehicles in our fleet, which we kind of refer to as our big box vehicles. So they have super high tech, state of the art, the latest technology from high resolution 360-degree imaging, GPS, IMU, LCMS pods, which are used for collecting 2D and 3D pavement distress detection, which is really the core of our conversation today. And then they're fully equipped with LiDAR sensors as well. On the right is our highly portable Maverick unit, which was developed in-house by us at Mandli. It's about a 3-year-old piece of technology that we developed back in 2016. It's 22 pounds, and we've mounted this thing on ATVs and backpacks, golf carts, even rail cars for a lot of our special projects that we've done here at Mandli. Looking here at some of our core deliverables, like I said, we support both our deliverables support both the public and private sectors. Our core deliverables from left to right, photo log, capturing that right-of-way imagery that companies love to use for validation and really a myriad of other things, to pavement distress, which we'll talk about in depth today, asset detection and extraction, which we use, which we get really from our LiDAR data, which is the fourth core deliverable. So going back to pavement distress is really what obviously we're here to discuss today. So without further ado, I will pass the baton over to Stan and Jacob to really take us the rest of the way and dive into our pavement preservation methodologies.
Thanks, Travis. Everybody can see my screen and hear me okay? This is Stan Burns.
Yep, we can.
Great. Well, today we'll present how Mandli has created a pavement management system, or PFES, a plan for every section of every road for their clients. And as Terry said and Travis said, Mandli displays this PFES information in ArcGIS, allowing users to view, edit, manage, and analyze the pavement data, whether it's in web map apps, operations dashboard, or integrating their own maps that they developed into this plan for every section of every road. To start off, I'd like to say that many agencies use sophisticated desktop business systems to manage their pavement, assets, etc. But communicating the results of desktop business systems can be challenging. It's not in the cloud, it's on a desktop. It's an expert system, meaning that only a few of the staff are actually able to operate that software. The ArcGIS platform solves this pressing challenge of communication by making this platform accessible across the agency. And finally, I'd like to say a word about PFES, a plan for every section of every road. In 1995, while working at the Utah Department of Transportation, or UDOT, I created a plan for every section of every road at Region 2, one of the 4 regions. We divided the road into logical sections, how they might have been built, maintained, the distresses, the functional class, traffic, and from that development of a plan for every section of every road, we were able to analyze and provide long-term preservation solutions for the department. UDOT to this day brands their pavement management system as PFES. Mandli uses the same phrase to articulate to clients how they might preserve their pavement system. Terry mentioned that we're going to talk about methodology of how to create a pavement management system. I'm going to use this slide repeatedly over the presentation to articulate these 6 points: strategic direction, agency culture, pavement inventory, pavement sections, project recommendations, and analysis. To start off, most agencies have a strategic direction, and most agencies concentrate on these 3 areas: mobility, fatalities, and infrastructure. Increased mobility could be add a pedestrian lane, add a bike lane, add ramp metering. 0 fatalities is an aspirational goal, but it's the only goal that's really valid or justified for an agency. And then preserve infrastructure is, we've inherited this transportation system from previous generations. It's our responsibility to wisely maintain that. Every year, I would help the executive director at UDOT produce the annual strategic report. It was a report of where UDOT was, where they are today, and where they want to be in the future. And it concentrated on these 3 areas. It was a report card that then the executive director would take to the governor and say, this is where we are, this is where we need to improve, this is the direction we're going. So if you have a strategic direction at your agency, it helps focus the staff of where we're going and why we're going that direction. If you were to ask most of the people at the agency I used to work for, they can name the 3 strategic goals. That is the power of articulating a strategic direction and the power of being wise stewards of the public dollar. So I've talked about strategic direction and the importance of it. I'd like to talk about agency culture next. I'm an engineer, but I don't start with the fancy software. I don't start with deterioration curves of pavement. I start with agency culture. And at UDOT, the agency culture revolves around this phrase, good roads cost less. In 1977, the director of research authored a paper on whether it is more appropriate to do periodic pavement treatments, or is it better to build the road and do minimal treatments over the course of the next 25 years and rebuild it. The paper looked at the various construction costs, mobilization, traffic control. It also looked at wear and tear on vehicles, reduced gas mileage. The end product was, the report said, it's more effective to do periodic treatments instead of waiting for it to fall apart and then being forced to do it worse first. It's very analogous to us with our vehicles. We change the oil in our vehicle at the appropriate time. We don't let the engine block freeze. We change our re-roof at the appropriate time at our house. But the most important thing about this study was the title of the study, Good Roads Cost Less. Today, if you're a new employee at my former agency, this is one of the first things you learn. The agency practices good roads cost less. They do periodic treatments to extend the life. When there's a new governor, the executive director will introduce this subject to the governor. Governor, we practice good roads cost less, and we have a plan for every section of every road. It's been rewarding for me as a engineering consultant working with states, and they've embraced the same idea. Periodic treatments will extend the life, reduce the cost of either the bridge, the sign, the guardrail, in our case, pavement. We've all seen these curves before. The goal is to make this ubiquitous across the agency. Everybody believe it, from the new engineer, the new maintenance staff, to the governor. So we've talked about the importance of strategic direction and culture. Now I'd like to talk about the pavement inventory, but I could have said pavement or asset inventory. Each one of these three strategic goals needs accurate information, whether it's mobility, fatalities, infrastructure. And that's the hang up at most agencies. They have data that's not authoritative, not trusted. They don't know what to believe. And just keeping up to date on what is new and what has been replaced is a very difficult task. So the benefit of using a company like Mandli is they'll drive the roads at highway speeds for you to your specifications. Travis covered a little bit about this, but this vehicle has 9 of these cameras on it. The resolution is 2,000 by 4,000 for each camera. They provide this solution, RoadView Explorer. It's on the web, integrated with ArcGIS. You're looking at an image right now, and Jacob will show you more of this later. The vehicle also has downward lasers. This is called LCMS, Laser Crack Measuring System, measuring every single crack, the width, the depth, the length, the rutting, the faulting, the roughness of the road, again, to the agency's specifications. The vehicle also includes LiDAR, 2 LiDAR heads in this case. It creates a 3D representation of the right-of-way, and from that, Mandli is able to extract for the client the width of this road, the width of the lane, the number of square yards of pavement, the signs, the guardrail, et cetera, all to an accuracy of about 2 centimeters relative accuracy. And then finally, Mandli provides this to the client as a solution in ArcGIS. And Jacob will show you this next, where everything's available at the click of a mouse. All you need is a browser and a login. You can look at any of the assets, any of the pavement, any of the image. So I will start this video for Jacob.
Thanks, Dan. So this is RoadView Explorer for the County of Hawaii. This is the main area that the county can come and access Mandli data from the web. So they can get to any of this data by either going to the Select a Route button, shown in the upper right, or clicking on the splash screen shown here. So from here, they can select a specific route or a street name if they happen to know it, or if they're looking into a particular area, they can actually come over to the map search, which is what we'll do now. So now we can see the big island of Hawaii, and all of the dark red and light red lines are just simply feature layers that are stored on ArcGIS Online. And that is basically showing where Mandli has collected data and where data is tied to those particular streets. So you can then go to particular areas by putting in an address or a Latin long, or just by zooming in on the map. So in this case, we'll just go to downtown Hilo. Stan, did you potentially pause the recording? It seems to be frozen on my side.
No, I did not. I just paused it now, though.
Okay, it just seemed to be locked up. So let's just see if we can.
Are you looking at the image right now?
I am. It just wasn't advancing.
All right, I'll start it again.
Okay, thanks. I'm still not seeing it advance. Is it working on your side, Stan?
Yes, it is. We're zooming
Okay, now I'm
into
coming up.
downtown Hilo.
Okay, so I guess I'll just pick up from here as this video goes on so we don't tie up any more of our time. So basically what we did was we just selected a particular route by double clicking on that map window. And now I'm just showing the extent of that street, which is shown in blue. We can also see our right-of-way images, and now we see the extent of the route on that route bar here. We can go to a particular section of the route. Say someone reported a pothole at milepost 1. We can get to that location by selecting the adjust route or route adjustment button. And Stan, it seems to be locked up again on my side.
Do you want me to describe this, Jacob?
Sure.
I hope everybody who's watching this is not locking up for them. So what Jacob is doing now is he was zooming into the image to look at a distressed part of the pavement. And if you look at that striped line and there's a pothole right there. So Jacob's going to advance one slide to look closer. Now he looks at the downward line laser that I talked about earlier, and it shows the pothole. You can see it green, yellow, red. Red signifies a severe crack. Yellow is a medium crack, and you can see the extent. You can see the lateral lines. The bright yellow lines are actual striping. The square box is categorizing all the lateral. In this image, Jacob is showing you the actual rut depth. And so at a click of a mouse, you can look at not only the image, but also the pavement distress. We also have the ability to do individual measures, but this is a turnkey operation where you just ask, I want all the block cracking, all the pothole cracking, I want the severity of it, and Mandli provides that on a frame-by-frame basis to you. We also have the ability to look at LiDAR. We can look at pavement distress, and here we're opening up the LiDAR screen of the exact place we are, and you can see signs, signals, light poles, power poles, the actual striping that we were just looking at in the image. You can see it in the LiDAR. And this is how Mandli actually extracts the length of those lines, the width of those lines, the type, whether it's a yellow line, a white line. This is an all-encompassing software. So we looked at images, we've looked at pavement. Now Jacob is opening up ArcGIS, the map, and all of the assets, whether we look at ADA ramps, barriers, catch basins, curbs, driveways, we can turn those on. We can sort. Some of these assets we can sort by good, fair, poor. Signs, for example, curb is another one. Barrier is a third. It gives the user the ability to look at either enterprise-wide, all the curbs, or that specific section of roadway. Here, Jacob has turned on polygons. This is actual square yards of surface area. It's very important for pavement management to know how many yards of pavement you're going to do rehabilitation on. Clicking on it, you can see all the metadata, the beginning milepost, the ending milepost, the width of the road, the type of material, whether it's asphalt or concrete, and the specific area. These areas we take out and we put this into the pavement management system. So when we come up with a cost, we know exactly how many square yards of pavement we are actually dealing with. And I think that's the end of Jacob's video. So I'll go back to my presentation. And so back to the methodology. We've talked about the pavement inventory or the asset inventory and how important that is for the three areas of mobility, safety, and infrastructure. And now let's talk about pavement sections. And here we actually take this universal data that Mandli's collected for the client, and we apply it to just one business issue, in this case, pavement. But we could have talked about bridges or signs or safety and mobility. So we're going to talk just about pavement sections. More, what do we actually mean when we say we have a plan for every section of every road? Well, in UDOT's case, they have 5,000 centerline miles and 16,000 lane miles. They break that up into logical sections, and it could be how they were originally built or how they presently maintained. If the client does not have as-built, or they don't know how, they don't have accurate records of how they maintain it, we help them build those sections. And the way we do it is we divide their road up into functional class. So first of all, we figure out where their interstates are versus their local roads, their surface type, concrete versus asphalt. Then we apply the distress. And the distress you're looking at here is the IRI, the roughness of the road. And there's a clear break at 25.7, where the road was very rough before and now it's relatively smooth. So if the DOT or the agency, the city, county, do not have sections, we will virtually drive the road and determine the sections for them based on distresses, and then we'll drive the road physically with the client and say, should we break the road at 25.7? At the same time, we'll add AADT and truck volumes. We want our goal here on sections to try to create homogeneous sections for distresses. We don't want sections that have high distresses and low distresses in the same section. At the same time, we do not want sections that have high volume traffic, high truck traffic with low truck traffic. We also include environmental issues, soil, rainfall, water table, into our selection process. The next thing we do is we normalize all the distresses. The map I'm showing you is what everybody wants to see, no matter where you work. You want to know the relative condition of roads in your area. We are showing you on this map of, this is the Big Island, roads that are good, fair, and poor. Green are good, poor are red. How we achieve that is we normalize the distresses from a scale from 0 to 100. 100 being perfect, 0 being very, very poor. And then we grade the road. If it's above 80, it's good. If it's below 60, it's poor, just like when we were in school. It's very analogous. So what I mean in practicality is a half an inch is a poor road. How do you compare that with a road that has an IRI of 150? Well, we normalize each one of those distresses on a scale from 0 to 100, and then add them together in various ratios based on what the client perceives their roads to be. At the same time, we normalize the traffic. Obviously, you want to work on roads that have high traffic volumes, but not at the expense of doing low volume roads periodically. And what we've found over the years, if a road has 100,000 vehicles and another road has 5,000 vehicles, the model is almost always going to select the road with 100,000 vehicles unless you raise the traffic to a power of 0.4. We work with the client to say, is it 0.3 or 0.4 or 0.5? So what that means is instead of being a 20-to-1 ratio on the example I just gave you, it's more like a 10-to-1 ratio. At the same time, we normalize soils and rainfall across the Big Island as an example. There are rainy parts of the Big Island, there are very dry parts. We factor that into our selection process. And then finally, what I'd like to talk about are decision trees. Think of these as triggers and resets. What triggers a specific treatment? And then if you do that treatment, what is the reset? What is the improvement you get? So this model quantifies when a trigger is set for crack seal versus mill and fill, and what the benefit of that reset is, numerical benefit. So we work with the client and the contracting community, which is very important, to say, what are the treatments you're used to doing? What are you comfortable with doing? Where do you not want to do treatments? Many agencies don't want to do a chip seal in urban areas. Some do. Many agencies don't want to do a a slurry seal in a wet, damp condition for construction reasons, but also for future stripping reasons. So the decision trees, what combination of distresses will trigger a treatment? And then more importantly, or just as importantly, is what is the value? What is the benefit of doing that treatment? And the reason why that is important, the model will take all the 1,000 sections that we have for an agency and rank them from 1 to 1,000, a benefit cost. So the cost we can determine from the proposed treatment and the square yards we're going to do. The benefit is a quantifiable benefit from the treatment. To give you a little bit more background of what I mean by triggers and resets, I'm going to show you typical treatments that an agency will do. PFES recommendations that we'll show you shortly in our model will recommend for the agency or the district or the functional class. These are all of the chip seals you should do. These are all the mill and fills. These are all the stone matrix you should do. Percentage breakdown. The model will recommend, if the cracking is just beginning, do a crack seal. If the cracking becomes severe, like a 60, it will stop recommending crack seal because there's just too much cracks to seal. But the other part that I wanted to stress is the reset. Obviously, you fill these cracks, your cracking index is going to go from maybe a 60 to a 90. That is, you can't get to 100 because you probably won't be able to fill all the cracks. But you'll get a benefit of sealing those cracks that will be in the model as a reset. But it's not going to do anything for the rutting. It's not going to do anything for the ride. So if your ride was a 60 before, it's going to stay a 60 after you do your crack seal. Chip seals, the model will restrict where you can do those for most agencies. Most agencies don't want those in urban areas, high-speed roads. Most agencies will put chip seals on in dry areas. The model will recommend crack sealing beforehand, applying the chip seal a year later, and then the model will credit a reset for cracks. They'll give a small credit for rutting. It will fill the ruts slightly. So rutting might have been a 70, it might go to a 75. The roughness might have been an 80, it might go to an 85. All those benefits are added together for the final benefit cost ratio of all 1,000 sections in our case. Microsurfacing, another treatment that's common, but the model will restrict it to higher volume roads with truck traffic and rutting and cracking. Stone matrix is a very expensive polymer modified stone on stone asphalt that is used primarily in urban areas, high truck volumes. Here, the resets are almost 100% for the cracks, almost 100% for the rutting, a very significant increase in ride, but the ride will still be a little bit rough. So this treatment, you might say, why do you do this treatment all the time if it's so much better for cracking, rutting, ride, fatigue cracking? The reason is it costs so much, and that's part of the calculation. The ranking is benefit versus cost. Finally, overlays. If the road is beginning to oxidize, if there's cracking, if the road is rough, the model would recommend an overlay. And finally, mill and fill. If the road is deteriorated to a point where preservation is not applicable, we'll recommend either a 2-inch mill, a minor rehabilitation, or a major rehabilitation, which is a 4-inch. This will bring everything up to 100% or nearly 100%, all those cracking measures I talked about. But obviously, this is the most expensive treatment. But the interesting thing, working with the clients don't have infinite budgets. They will not, most clients will restrict this kind of operation just to high volume roads. So the model will not allow this kind of a treatment, even if the road is in severe condition on the low volume road. Recognizing that there's only limited budgets to maintain your pavement. So now what we're going to try to do is we're going to see if we can do the video, and Jacob will talk again. And Jacob, if it lags, then I'll take over.
Sounds good. So this is the County of Hawaii Plan for Every Section, or PFES. And this is built on the Esri's operation dashboard. So here we have the Big Island of Hawaii again. All of the layers that you can see are the current plan for every section for Hawaii so far. And we're just going to zoom into Hilo to take a look at some of these sections. So just like Stan mentioned, all of the layers are being represented with the overall condition. And we can see in the legend, good, fair, poor, just like Stan mentioned as well. If we want to look at more detail of a given section, we can click on one of them and see the attribute table and look at any of the stress information, the traffic information, surface area, what have you. So we can close that. Another way of representing the overall condition, aside from on the map, is also by representing it on a chart. So that's what we have below. So this is, again, the overall condition, good, fair, and poor of our roads that we put in so far. And we have the centerline miles of each of the sections shown as far as the distribution of the overall condition. The overall condition is actually made up of components, which would be ride, rut, fatigue cracking or load cracking, and environmental cracking. These components are important because it allows us to see what is driving the overall condition. So for Hawaii so far, we can see that there is not actually a lot of rutting, but the roads are relatively rough, and there's also quite a bit of cracking that can be seen as well. So from these components, just like Stan mentioned, we were able to come up with recommendations, and he's kind of already gone over that. So a lot of that was based off of his engineering judgment based off the time at UDOT, and also working with the Hawaii engineers as well. We can see the recommendations shown on this pie chart in the lower right. And then we can also see represented in a different way on this bar chart directly underneath our map. Again, it's just shown using the centerline miles of the roadway, but we did something slightly different where we've actually put them into bins, priority bins, 1, 2, and 3. So 1 is the most important. So these are mainly driven by the traffic load. It's kind of alluded to by Stan earlier. Also, any roads that might be on the NHS, the National Highway System, or any treatment that might be really important that we always want to include. So for instance, fog seal. Fog seal is always a really cheap but important treatment that should be done if it's being recommended. So that's why it's in priority 1. We'll just actually select the major rehab in priority 1. So this is more expensive, but it's likely on a very busy road. And sure enough, one of the sections that we've filtered down, and we can now see is just selecting one particular section here. And Hilo likely has a lot of traffic to it. If we come over to the functional class pie chart that's been filtered out, we can see that the sections that are tied to this priority 1 major rehab are minor arterial and major collectors, so roads that have more traffic on them. So that explains why they're in the priority 1 bin. I've just unfiltered all of them by selecting the same treatment that I just did. So now we're seeing everything again from here. In addition to the recommendations, we then, like Stan already mentioned, we also wanted to know what the benefit for the cost incurred by our given project would be. So just like Stan mentioned, we took the surface area information from those lane polygons that we showed in RoadView Explorer and the unit cost for any one of those given recommendations, and then compared that against the benefit that Stan mentioned, how much the road's used and how big of an improvement would be done with that given recommendation as well. So we were able to then rank our projects from the greatest benefit to the least. So we're just selecting our top 3 projects here. So these are just 3 sections. It's a little difficult to see, but there's 2 small sections in red towards the north side of this part of Hilo, and then a long stretch through the university. This makes some sense since these are probably more heavily traveled roads, so we're getting greater benefit for that. We can see that the recommendations for these 3 sections are 2 preservations, a micro seal and an SMA, and then also a major rehab. So since this was in our top 3, it's likely that major rehab has a lot of traffic, which again makes sense since we're in downtown Hilo. So we'll just deselect all of these. So this is a lot of data for people to get a handle on at first. So we wanted to make sure that we had the tools available for people to look and understand this data. So we've provided our initial draft of this PFES manual. So Stan has kind of shown some of this so far. So this kind of gives transparency and insight into what decisions are being made and what each of the fields mean. People can download a copy of this as well. Users also have the ability to download a raw version of the data if they want to look at it in other GIS platforms or other Esri products, so they can at least take the source data and then do other visualizations or analysis with it, potentially put it into insights. And then for additional help, we also have a what is PFES option, which basically just opens up a Vimeo video that just kind of runs through a real introductory kind of step-by-step walkthrough of PFES. So with all of these pieces of information, we hope that people can be able to prioritize their projects and also be able to rationalize or justify their costs for doing these projects. I guess with that, I'll hand it back over to Stan.
So we've gone through all of the 6 steps from strategic direction to analysis. This is based on my career when I was at the Utah Department of Transportation, but it's been beneficial as we've talked to clients to create a roadmap. Just don't go out and buy a fancy piece of software, but understand what's really important to the agency. Create a culture. And so in summary, the beauty of ArcGIS and Esri and integration of Mandli's PFES together, it's a transparent process. It's not a black box. Our desktop applications that run our day-to-day businesses are great, but getting information out of those in a timely manner when you're meeting with the mayor, city council, and they're asking what ifs, it's wonderful to be able to go to your browser, log in, show them real-time information. What we try to create here is a logical way to manage your most valuable asset. Break the road up into logical sections, create a systematic process. Always remember, brand it if you can. Good roads cost less. We have a plan for every section of every road. And what that hopefully does is the public gains trust in what you're doing. The biggest budget you have is maintaining your pavement. It's very effective when you go and talk to the public. This is the condition of our roads, and this is why we're doing this road next year. The program is all based around what gives the greatest benefit for the least cost. And hopefully our presentation today gave you a sense that we're on the right track. So now, Terry, I think we'll open it up for questions, but we'll also, if we don't have time, we want to thank Esri again for giving us this opportunity to present this product.
Okay, well, thanks, Stan and Travis and Jacob. So we are going to open it up to questions. If you haven't already, feel free to type your questions into the question box, and we're going to start off. So the first question is, when evaluating distresses, do you treat intersections differently? And I think the feeling is that, buses and trucks probably have a greater impact on deterioration and intersections. So can you speak to that a little bit?
Yeah, I'll let Jacob jump in. From my experience, no. But Jacob, from Mandli's experience, have any of your clients ever asked you to do that for them?
Well, I guess for the County of Hawaii, a lot of the way that we actually broke up some of the sections was based on kind of known or perceived maintenance of the section. So we'd often use the right-of-way imagery as we went through, and also the distress information to help determine where we should make those sections. So basically, long story short, if it seems that some agency is actually maintaining the intersection differently than the roads coming into it, then we would actually break it into its own section. However, if that didn't seem to be the case, then it would just kind of be lumped into the rest of the section that was already existing. So hopefully that helps answer that question.
Yep. All right. Thanks. So another question: if an agency already has, if they've already collected their pavement data, could they still implement PFES?
Yes, they could, and that you're doing the hardest part. You're putting out an RFP, or you're collecting it with your own resources. You're categorizing distresses, good, fair, poor. We could easily take that, work with that agency. Again, load the traffic, your environmental factors, create the sections, and then run the model. So yes.
Okay. All right. And another one, for the Hawaii project, what equipment did you use to perform the inspections? Can you maybe just go over that again very quickly?
I'm not sure I understand the question. There's a QC and QA process, if that was what the question is.
Stan, I think I can jump in.
Yeah, go ahead, Jacob.
Yep. I think they're just curious about the instrumentation. It sounds like they might have just jumped in late. So to collect the pavement data or perform the pavement inspection, we used the LCMS, LCMS2 pods by Pavemetrics to collect the pavement data. So that did the bulk of the automated distresses. And then for any of the more nuanced distresses that couldn't be taken out automatically, we used those same downward 3D and 2D images to help rate any manual distresses too. So hopefully that answers that question.
Okay. And, part of the process, I think, as well, is that, you guys actually worked with the DOT to really sort of define the way that the distresses would be characterized and categorized, and worked with them on the pavement segmentation and such. So it is a little bit of an iterative working with the local agency. Yes?
Yeah, that's a good point, Terry. It's what's called a data dictionary. You sit down with the client, and the client defines, this is what we want. We want cracking. We want lateral, longitudinal, block cracking. And then we want the severity to be noted as if it's less than 1/4 of an inch. We want that as fair cracking as opposed to poor cracking. Rutting. We want all the lanes to be driven. Or no, we just want the outside lanes. We want all the ramps to be included in your pavement distress collection. And we also want the ramps in PFES, by the way. So there's a long process of sitting down with the client and saying, exactly how do you want your pavement reported back to you? And the same process happens with assets. If the client wants to know, I also want to know all the guardrail, all the signs. Well, what is a sign? A sign is, they define it for us: the height, the width, the offset, the MUTCD, the color, the legend, etc. It's a back and forth iterative process, as you suggested, Terry.
Okay, all right. So there's another question. Do you allow for time series analysis? That is to maybe take a look at predictive modeling and so forth. So do you look at over deterioration over time, and then so anyway, I'll let you answer.
We have a long-term roadmap for PFES. We just released PFES 2.0, which incorporated environmental factors, ramp analysis. 3.0, we're going to start looking at predictive modeling and perhaps deterioration curves, being able to forecast 5 years ahead of time. So that's on the roadmap that Mandli has.
Okay, and
present, no.
Yep. Okay. So the question: how long did it take to get the 5,000 centerline miles from gathering the data to providing the distress and getting it all loaded? I guess it was time to from initial to how long did it take to really do the project delivery?
Well, I'll give you rough numbers, and Jacob, you can jump in, fill in anything I've missed. But it takes Mandli, let's say, 3 months to collect the 5,000 centerline miles. I believe it takes another couple of months to do the extraction. Once the extraction is placed, Jacob and I are simultaneously working with the client about, okay, where is the functional classification? Where's your traffic? Where's the truck traffic? Environmental factors. So we've set up simultaneously PFES. We download that data, and then we provide it back to the client within a couple of months. So I gave you some numbers there, and it's probably about 8 months from beginning to end. But Jacob, I don't know if you have a difference of opinion there.
Yeah, I think you've just about covered it, Stan, as far as the entire project. If you'd want to look at this from square one of starting to collect the data, processing it, and packaging it up into PFES, I'd probably say that would be fair. If it was mainly just the data itself, as far as data collection and reporting, at least the raw data, like those polygons and the distress reports broken down into, let's say, 10th mile or 100th mile sections, just that basic process is probably about 6 months, I'd have to guess. If we would start like in winter in Hawaii, we might be done by maybe like springtime, late springtime, May, perhaps. But then a few more months potentially to kind of shore things up with the PFES platform in Esri.
Okay. Another question, someone's saying that we have 3 intersections on diagonal streets. How do you handle, I guess, diagonal streets and the complex intersections?
Well, from a pavement distress, you'd be driving both directions, obviously. And if the client wanted all lanes, as Jacob mentioned, then they would develop the stresses by hundredths of miles and tenths of a mile. If you wanted, depending on the predominant street, you could have that as your distresses and cut out those distresses for your secondary street. PFES then would recommend either one of those as the section, most likely the predominant street, and do the analysis and make the recommendation. But part of PFES that we want to develop for insights is, are there 2 different treatments over 2 different years, one for the predominant street and one for the secondary street? With insights, we hope to create hotspot analysis for years 1, 2, and 3, and see if there's any conflict between those. And that would be something where we would recommend doing both streets in one construction season. Jacob, do you have anything else you want to fill in there?
No, I think you've covered it, Stan.
Okay. Another question. Can PFES be used with an existing pavement management program? For example, if we're currently using micropaver, would it make sense to also use PFES to help us come up with a pavement program?
If I understand correctly, we could take the results from Paver. If it's in shape files, we could download that into PFES and display that in ArcGIS like we showed you today. I'm not familiar with the output of micropaver, but what I want to stress is it's very powerful when you're in a meeting and you can open up your browser, log in to ArcGIS, and show this live. So if micropaver can do that, that's great. But if it can't, we'd be happy to talk further about taking your extracted data and putting it into PFES.
Okay. And let's see here. There's a question relating to Maintaining data over time, can you maybe talk about how agencies do that? So you do the pavement collection, and then how do agencies typically maintain it over time, the data and the program?
Well, it's more of an issue, I believe, with assets than pavement. The federal government with MAP 21 requires that the national highway system be driven on a 2-year basis, I believe. And what we found at some agencies, they want to drive the road every year for pavement. This is such an important asset. Assets are, in general, are more difficult to maintain. I'm talking about signs and guardrail. And so what Mandli will do, they'll create a base map for the agency. These are all 150,000 signs you have. These are all so many miles of barrier have. Updating it then, do you use collector 1, 2, 3 with your maintenance staff? So when they put in a new sign, a new guardrail, it's updated into your data. We would take your pavement history that you've done for the past year, load it into PFES, so we would see that in PFES as a new project. But the only way to really capture distresses is to drive it at highway speeds with these lasers that we've talked about. Updating data is always the challenge, but you need to start with a base so you'll have accurate data to begin with. So the task of updating it isn't so monumental.
Okay, well, I think that concludes our webinar. We'd like to thank the folks from Mandli, Travis and Jacob, and Stan from Integrated Inventory. Really a great webinar. As we mentioned, the slides from today's presentation will be made available on the GeoNet Departments of Transportation group. And if you give us a couple of days, we'll actually have this webinar posted on the website. So again, we'd like to thank all of you for attending, and we look forward to seeing you at next month's DOT webinar. And until then, thanks again, and bye-bye.